The unified field: how spinning light shapes our universe in quantum information. Holography, or QIH, the universe isn't made up of solid particles but of spinning light, quantum state vectors, or QSVs. These aren't merely energy, they're packets of information. Each QSV spins at the speed of light and carries four essential elements: amplitude, frequency, direction, and phase. Imagine the universe as a grand projection. From a singularity, the universe's origin point, QSVs project outward and imprint onto a spherical surface known as the event horizon. Every point on this horizon acts like a detector, capturing the encoded information. This process forms the geometry we perceive as space, time, matter, and force. Now let's break down how each fundamental force emerges from these spinning vectors. Gravity, the curvature of coherence. Gravity in QIH arises from the collective alignment of many QSVs. When these vectors align in phase and frequency, they generate smooth, coherent curvature. This bending of space-time isn't a pull, but a shift in probability. Matter follows the most likely path through this curved geometry. The more QSVs spin together, the more pronounced the curvature, and what we call mass is actually the total angular frequency of this coherent pattern. Electromagnetism, the geometry of spin angle. Electromagnetism emerges from how individual QSVs project onto qubits at specific angles. When the angle is just right, it creates curvature that becomes electric charge. As QSVs move, their spin generates magnetic fields. Together, these fields form the electromagnetic force. QIH reveals that the fine structure constant, which defines the strength of this interaction, isn't arbitrary. It stems from the electron's spin frequency in the projection geometry, aligning perfectly with experimental values. The weak force transformation through phase shift. The weak force occurs when a QSV rotates slightly out of alignment. This phase shift disrupts the projection, allowing particles to change identity, like neutrons converting into protons. Because this misalignment quickly decoheres, the force is short-range and mediated by massive particles, W and Z bosons. Their mass and short lifespan are a result of their unstable spin geometry. The strong force locked interference. The strong force results from three QSVs locking into perfect phase alignment, corresponding to what physicists call red, green, and blue color charges. This forms a tightly bound interference pattern, creating protons and neutrons. Unlike other forces, the strong force doesn't allow its components to separate. If one QSV tries to pull away, the pattern collapses and new QSVs emerge to maintain balance. This phenomenon, known as confinement, ensures certain spin symmetries stay intact. The bigger picture: one field, many expressions. In QIH, the four fundamental forces are different expressions of how spinning light interferes. Gravity emerges from collective spin, creating spatial curvature. Electromagnetism arises from angled spin projecting fields. The weak force results from temporary misalignment and phase flipping. The strong force stems from locked spin symmetries in three-particle systems. These forces are not separate interactions, but modes of the same universal projection. Even the constants we use in physics, the charge of an electron, the strength of gravity, the fine structure constant, emerge naturally from the spin frequency and projection geometry of light itself. QIH offers a revolutionary way to understand the universe. Everything, forces, matter, motion, comes from how spin is organized and aligned at the smallest scales. We are not separate from the universe, we are part of its projection. We are woven into its pattern. So the next time you look up at the stars, remember that it's all spinning, light shaping reality, and you are part of that light, woven one spin at a time.